Hello and welcome to another video. This shape is called a Norman window and it is a semicircle mounted on a rectangle. So architects use it. You see it in the design of hallways, you see it in the design of the entrance to cathedrals and temples, and this is actually the shape of an epitaph, okay? If you write something lovely about a loved one that has passed away, that's what the gravestone looks like. So this is often used. The question today is, if you have a limited amount of material, how would you shape this? What radius would you give it so that you have the maximum area? And that's what we're about to do today. Well, on the way to getting there, I will be touching about some of the subjects like I wrote them here so I don't forget. What's the domain? What's the maximum? And what's the minimum? We'll talk about all that on the way to getting actually the maximum. If you find this video too slow for you, there's something really fun about my videos. Play them at a faster speed and you have a lot of fun laughing. I do that too. Let's get down to this problem. So, we're given already the perimeter of this, and we know that the perimeter of this shape is basically just going around the shape. We know that this is the radius, and this also will be the radius. This would be the radius, this would be the radius. So we can as well say that this part is 2 radii, okay? We don't know what this height is. It has nothing to do with the radius. And it's a rectangle, so let's just call this x and call this also x. But remember, all we're doing is just in terms of the radius, because this actually is not significant. You're going to see as we continue. So right now the perimeter is the length of this arc plus x plus 2r plus x. So we can say that the perimeter P is equal to the length of this arc. What's the length of an arc? Or the length of a semicircle? Well, the perimeter of a circle is 2 pi r, and so half of that will be just pi r. So we can easily say it's the length of this, which is pi r plus x plus 2r plus x. That's going to be 2r plus 2x. Okay, let me get rid of this. So at this point, that's what we have. That's our perimeter. So let's go to the next thing. Let me put this x inside so it doesn't confuse us. Let's put the x's inside. Okay, so what's the area of this? And why do we need the area? Remember, the first thing we want to get is the area, but the area is supposed to be expressed only in terms of r, because we don't know what x is and we don't really care. Wait, let's isolate x first. Let's take x out of this. So because we're given the perimeter to be 16, I just want to write a general expression. So let's not use 16 yet, because 16 could be any number, okay? The perimeter could be anything depending on how much material you have to build whatever you want to build. But what's important is that we have the area. Let's see. So if we isolate 2x, we're going to have 2x equals perimeter minus pi r minus 2r. So which gives us that x equals p minus pi r minus 2r over 2. That's our x. Okay, so now everything we have is in terms of r, and that's really what we're supposed to do, because we were only given this from the beginning, the radius, and we're not even given this. We figured that out, that it's going to be r on this side and r on this side. So now let's do the first thing. Let's find the area. I'm going to start my work from here. Okay, so what's the area? So area is the area of the semicircle plus the area of the rectangle. What's the area of a semicircle? It's half the area of a circle. Well, the area of a circle is pi r squared. So half of that is going to be pi r squared over 2 plus, what's the area of the rectangle? It's length times width, which will be 2r times x. So that's going to be 2rx. That's it. Well, we would stop here. It's just that there's an x, okay? There was no x in the question. We don't want to have x there, but we have isolated x from this equation to be this. So we're just going to replace this here, and we're going to get it's pi r squared over 2 plus, this is going to be 2r multiplied by this. So I'm going to write p minus pi r minus 2r over 2. Let's open this up. This is going to be pi r squared over 2 plus, if you multiply this in and just leave this, this is going to be 2 lmnopqr. So p comes before r. I'm going to write 2pr, and then I'm going to have minus, this is a constant, so I'm going to write 2 pi r squared, and 2r times 2r is going to be minus 4r squared, but all of these will be divided by, oh no, I could have just cancelled this too. But I left it because I want to add something on this side, okay? So you could do that, okay? But I don't want to do that because this is what I have. So I have something over 2 plus something over 2. So if you were wondering, why didn't you just cancel that? This is why. Now I can just put everything on one line, and this is what my next expression is going to be. It's going to be pi r squared. There's another pi r squared here, minus 2 pi r squared. Then I'm going to have plus 2pr minus 4r squared all over 2. Beautiful. That's my area. Okay, so let's write the final thing here. So my area now will be, if pi r squared minus 2 pi r squared will be negative pi r squared. So we're going to have negative pi r squared, and we have 2pr minus 4r squared. So we have plus 2pr minus 4r squared. Well, that's it. There's nothing else. So because this is specific to this question, they already told us what the perimeter is. It's 16. That's the only substitution I need to make. Otherwise, this is good as my answer. Okay? Or I can collect the like terms and put the r's together. You know what? Let's put them together. Although I don't care, but let's just do it. So this will be equal to negative pi r squared minus 4r squared, and this will be plus 2pr, okay, which will be equal to, this is going to be, what's common? R squared, so it's negative, oh, where's the 2? That's over 2. Come on, don't do that. Divided by 2. Okay, this is also divided by 2. I almost forgot about the 2. Okay, it's right there. So now we can actually split this. Let's put this together. So this is going to be negative pi minus 4. You have r squared, and then here you have, that's over 2 plus, if you divide this by 2, you're going to end up with PR. Negative pi minus 4 r squared over 2 plus 16r. This doesn't really look pretty. Let's take out the negative sign. So it's going to be negative pi plus 4 r squared over 2 plus 16r. That is the area of this particular one. Remember, you could have left the p instead of writing the 16, but because we wanted to get the exact answer for this, that's why we did that. The next thing is the domain of this. Now, this is a function, and if you look at it very well, It's a quadratic function actually. It's a quadratic equation or a function, okay? So this is as if you've written ax squared plus bx. Okay, your a is negative pi plus 4 over 2, and this is bx, where your b is 16 and x is the variable, okay? So generally when you have a polynomial or a quadratic function and you're asked what the domain is, well, generally all quadratic equations will have a domain of negative infinity to positive infinity. Well, because you never use infinity, that's why you use this. You don't use this, okay? So the first thought that would come to your mind is, well, that's my domain. But no, you can't take this as the domain of this because you're dealing with geometry. In geometry, radii or a radius cannot be a negative number. So you can't get to negative infinity. The farthest to the left you can get to is 0. Okay? That's the farthest, that's your boundary, because you can't get a negative radius. That's one way to look at this. So if I were you, I wouldn't even do any calculation. I know that the radius cannot be less than 0. The worst that could happen is that we have a radius of 0, which means we have nothing. Okay? So in reality, the worst that could happen is that you have nothing, no radius. Okay? But that's one way to get the, so let's write domain. That's the next question. Okay? The domain has a left boundary, a lower boundary or a lower boundary of 0. What will be the upper boundary? Well, I'll also show you another way. Let's go to the picture. Let's come back to this picture. Okay. Remember, the perimeter is fixed. Okay? But how you change the radius affects the area that you get. Okay? Now, let's go back here since we have the perimeter to work with. You notice that the perimeter is the sum of pi r plus 2r plus 2x. What are the maximum and the minimum values of r? Look at this shape. The more you increase, let's talk about increasing first. The more you increase the radius of this arc, it's going to go, so the arc is like this, just watch me. And then it's going to spread out. What's happening to x? X is getting smaller. See how x is bowing down to you? X is going down. And x is going down. So over time, the wider this becomes, the greater the radius, the smaller the value of x. By the time the radius gets to the largest point, x would have zeroed out. So you can look in this expression and say the maximum value of r will happen when x becomes 0. Okay? The maximum value of r will happen when x becomes 0. Let's find out when x becomes 0. Okay? Let's quickly do that. So we have 16 is equal to pi r plus 2r plus 2x. When this becomes 0, you're going to have 16 equals pi r plus 2r plus 2 times 0 is going to be 0. If you isolate the radius, what you notice is that r will be equal to 16 over 2 plus pi. That is the largest value of r you could use. And that's what I'm going to write here. 16 over 2 plus pi. Let's go back again. Let's assume we're doing the reverse. We're trying to make this smaller. So this arc is becoming smaller. X is getting larger. X is getting larger. X is getting larger, okay? The only time x will be maximum, or the only time you'll have the smallest value, is when it just ends up becoming 0. Just like this became 0, r2 will become 0. Okay? So that's the least you could get for this. So this is the domain. The domain of this function is between 0 and 16 over 2 plus pi. Remember, 16 is still the perimeter. So this 16 could be any number, but this will always be what the maximum radius will be. This would be the minimum radius for all Norman doorways, or whatever you call it. Okay? So, Norman window. Okay, it's a Norman. Oh, you see these in windows too. Should I leave this? I need the space. Okay, I'm just going to leave it. Okay? So, because it's a quadratic equation, what shape would it have? The coefficient of A in this quadratic equation is negative. That means it's going to be a maximum graph. And look at this. That's what I think this graph is going to be like. Why? Because when the radius, when the area becomes 0, it means this expression becomes 0. It means, I don't know what we're going to get, but let's say a quadratic, it goes back up and comes back down. Where does it come back down? Well, that's the end of it. Remember, that's the domain. Okay? So the domain of this whole thing, the area will not be negative, so it goes from here to here. And this point is that point that we have marked. It's 16 over 2 plus pi. And this point is 0. But there is a maximum area. Is there a minimum area? Well, the minimum area is the 0. So at this point, since we know what the domain is, we want to find what this point will be. This point is always at the vertex. And that's where the maximum area will happen. So we want to find the maximum. Maximum area is at the vertex. Okay, so what's the vertex? Remember, the equation of the vertex, okay, is where r is equal to minus b over 2a. At this point, this is our a and this is our b. Okay, so this is equal to, minus b is going to be minus 16 divided by 2a. 2a will be 2 multiplied by this, which will be equal to 2 multiplied by negative pi plus 4 over 2. Okay, so this gives us, this will take this out, and what is left will be 16 over pi plus 4. This is the value of the radius, okay, at the maximum point. So let's just compute the maximum area, and we just need to take this number, plug it into the area formula, and whatever we get will be the maximum, because this r is the radius when the area is maximum. So let's go. A max will be equal to this times r squared. That's negative pi plus 4 over 2 multiplied by r squared. Well, r squared is this squared. That's 16 over pi plus 4 squared plus 16r. So that's plus 16r. Well, r again is 16 over pi plus 4. So that's what we have. Now let's just go straight to the algebra. Now this is 16 squared. That's 256. 256 divided by 2 is going to be 128. So I'm just going to write that. The negative sign is there. 128 divided by. This is going to be, if you square this, you're going to have 2 of it. And you're going to have a square of it. But this will cancel one of it out. And then you're left with pi plus 4. And this is plus. 16 times 16 is 256 over pi plus 4. So at this point, we're just subtracting this from this. And this is half of this, so what we have left is 128 over pi plus 4. So right now, your final answer for the vertex Well, this is the maximum area. Let's just write it. Okay, the maximum area is 128 over pi plus 4. You notice what 128 is? It is the square of the perimeter divided by 2. So for all Norman windows, the maximum area is half of the square of the perimeter divided by pi plus 4. It doesn't change. Okay, so what's the vertex? The vertex is now 16 over pi plus 4, and the maximum area will be 128 over pi plus 4. Interesting. Okay, if you learned something in this video, or if I made it clearer, just make sure you give it a thumbs up, leave a positive comment in the comment section. If your comment is negative, make sure it's constructive criticism. Don't just say something that even you don't like. Okay, say something nice. Okay, and I'll see you in the next video. Until then, don't stop learning, because those who stop learning have stopped living. Bye-bye.